Jasmine and Cypress. Oh yes, one of our sponsors. Woohoo! Okay, so that's awesome. Cypress is an incredible product, um, and I like the creator of Cypress. When he gave me the first demo of Cypress, I was just completely blown away. And then when he gave me the next demo of Cypress, I was completely blown away again. So it's some awesome stuff, and Adam has also written a book on this topic, and so I'm gonna let him take it away.
Cool. So can everybody hear me? We're good? All right, so yeah, like Toby said, my name's Adam Morgan. I wrote a book that I published earlier this year, the Angular Tutorial, 500 pages of Angular material and automated testing. So if you want to check that out, it's available at theangulartutorial.org, and you can also buy it on Amazon. If you want to learn some basic JavaScript or some Angular tutorials, I write some free ones at codecompanion.io. It's my personal blog. And then the code repo for everything that's covered in this talk is also available on GitHub. And I've posted all these links on the Meetup link as well. So the first thing I want to talk about is the test tooling landscape, like all of the tools that you're going to use in testing, because it can get kind of overwhelming. The first one, specifically within Angular and some JavaScript frameworks, is Karma. You don't really do too much with Karma. It just kind of runs your tests. So if you've ever used Angular and you run ng test, that's running Karma. So you don't interact with it too much. After that is Jasmine. It's the testing framework that you actually use to write your tests. So Angular comes bundled with Jasmine. It's a pretty popular one out there. Some other ones, Mocha, Ava, Chai, and Jest are some pretty popular ones as well. And then finally, there's Protractor, which is used for end-to-end testing, which actually opens up a browser, clicks around, and does the automated version of what you would do if you were to open your application. It comes bundled with Protractor, but if I'm being honest, don't use it because it's kind of a nightmare. I'm not just saying this because Cypress is a sponsor, but Cypress is awesome. It's seriously an amazing tool. It takes off so much stress from end-to-end testing, so I can't stress it enough. Protractor, you'll run your test, it'll work one time, you run it again, it doesn't work. Cypress pretty much always works exactly as you expect it to, so can't say enough about Cypress. Now as far as why we test, there's a lot of confusion as to why we would test our code. First thing is that we just want to verify that our code actually does what we think it's going to do. So you write tests, you say, okay, this chunk of code is going to do this, and then you have a failing test, you write a test, and you get your code to make that test pass. Some other things is you want to avoid software defects. So if you know that, hey, my code is supposed to do this, you write a test, it's passing, somebody else changes some code, now it's not passing, you know that something has changed that caused that test to break. And then finally, it allows you to avoid manual QA. I've worked on teams where there isn't automated testing in place. Somebody will make a change to some code, they'll push it up, and then somebody else on the team kind of runs to their computer to make sure that their feature still works. That's a nightmare. You should never have to have that on your team. You don't want that. It's very time consuming. And it's, especially when you get to end-to-end testing, if you're constantly going back to your application and running through some like user registration form or some sort of process, if you can just automate that, you can just click a button, it runs through it, you know that it still works, so you don't have to keep doing this over and over. You can actually work on writing new features instead of testing something that you did months before. Now I want to keep this not like Angular specific, because for me the important part is that you kind of get why you should test. So I don't want to get too Angular specific with this. But one of the important concepts that kind of trips people up is how and what they should test. So the way I like to explain this is to imagine that you have some sort of alien AI that comes down to Earth. And this alien AI's name is Adder. And he wants to take some sort of computational processing away from us so that we don't have to add things. We can just ask Adder to do it for us. What we would do is we would ask Adder to add certain things, right? We would give it some math problems to make sure that Adder can add. So we would say, all right, like what's 2 plus 2? Adder says 4. We say, what's 2 plus negative 1? It says 1. We say, what's 2 plus 0? It says 2. What we're doing here is we're setting a bunch of different test cases for addition to make sure that Adder is giving us the answer that we expect. And in testing, this is what we do. We don't care how the code arrives at the answer necessarily. We don't care how Adder does it. Adder could be doing it in its head. It could be some supercomputer. It could be telepathically communicating with something. We don't care how Adder gets to that answer. We just care that we get the right answer. And when you're coding, that's a big thing, because one mistake a lot of people make is they test the implementation. They test what's inside of a function rather than what comes out of a function. And that's the key point with testing. You're just making sure that you get the answer you expect. So if we had something like Adder, this is how we would test it. We start off with what's known as a describe. It kind of groups all of the functionality of a larger piece of code. So in this case, it would be like an Adder class. And then within it, we have these it blocks. So like our test cases say, it should be able to add 2 whole numbers. It should be able to add a whole number and a negative number. It should be able to add a whole number and a 0. And when you write tests like this, it kind of reads like an English sentence, right? Adder should be able to do this, should be able to do this. So whenever a test case fails, you kind of have this English explanation of what your code can't do, which is why a lot of developers say that your test kind of serves as your documentation, because it's the first consumer of your code. When you're writing a test, you're calling your code as if it already exists, even though it doesn't, and then you make the test pass to get the test to pass. So here, what you do is you have these little things called expect. This is where you put the code that you're testing. So here we have like adder.add 2 plus 2 and 2. And then after that, you chain it with 2 equal, which is known as a matcher. So there's like not 2 equal, 2 be greater than, 2 be less than, a bunch of different matchers like that. But here's your actual code, and then here's the expected value that you actually put in there. So when you actually run like this, or when you run these tests, you get a printout like this that kind of describes your code in plain English. And when it fails, it's a lot easier to debug because you already have like a written description of why it's failing. So getting into Angular specifically. One of the bad parts about tests is there's a lot of boilerplate setup. But basically what's going on here is you have a couple imports up here. Those don't need to worry about that too much. But within Angular specifically, you have this thing called Testbed. And this is what configures your testing site. So this is where you're basically saying, this is the service that I want to test, the user service that I want to test. And then below that, you do testbed.get, which is basically saying, give me an instance of that service that I can use within this test and interact with. So the very first test down here that's pretty basic is just saying that user service should be truthy or that it exists. Over to the right, we have our first method. So if we have an all method that's just returning some sort of hard-coded collection of users, say like you're on an about page of a company, you have all of your employees, you put a little mock response there. So you just throw in a sample of what that might look like. And I'll get to why we mock in a minute. But you create a little sample user set here, and then what we do is we do this spy on thing. Spy basically allows you to spy, I hate to use the word in the definition of a word, but you're basically saying keep track of this user service all method, and whenever it's called, return an observable of this user response mocked object that you've created. And then below that, you do user.all, you subscribe to that observable, as Rachel talked about, and you set the response to this little response variable you created up here, and then you set your expectations. So you're saying that response that we get from the observable should be equal to that object that we specified above. So then when you get into the service, you implement that. Again, these could just be like a collection of employees, but that all method just says return an observable of those users. So again, if you do like test-driven development, you write a test, you get that to in a failing state where the code hasn't been written yet, and then you write the code to get that test to pass. This is why people refer to it as documentation, because you are the first consumer of your API. You're the first consumer of whatever code it is that you're writing. So you kind of get a sense of how it's going to be to use it, because you're the first consumer of it. All right, so that was a simple example with a hard-coded set of users. If you're going to actually hit an API, so if you're going to actually make an HTTP request, again, we start off at the top. I just took a sample response from an API request. Pokemon API, which is free to use. And again, you have the provider down here, the Pokemon service that we're going to be testing. And above that is this HTTP client testing module. This is a module that's given to you by Angular that basically allows you to interact with the HTTP requests that are going out and coming, and the responses that are coming in. So it gives you a handle on HTTP requests so that you can kind of do some things with it. And then down here, again, we get an instance of our Pokemon service, and then we also get an instance of this HTTP testing controller. This is what allows us to kind of track and make verifications about the HTTP request itself. So if we come over here, we have our Pokemon service. This is us actually calling the service method. So we say Pokemon service.findByName. We pass it this Pokemon name up here that we've hard-coded. We subscribe to the response, and we just set the result to the response variable up here. And then down here is where we actually make our tests. So again, using this HTTP testing controller, we're saying that this Pokemon service should make a request to this endpoint. That's our expectation. And then once that request happens, we want to flush or basically return this Pokemon response that we have up here that we've mocked. And then down here we just say we have our expectation that the response from this service call should equal this mocked response up here. And then there's this little thing, http.verify, which typically don't need, but it's just this thing that says make sure there are no additional outgoing requests from this method. There should only be the one that we've actually specified here. And then to implement that service, we have our HTTP client up here. We have our findByName method. All that does is make a GET request to the Pokemon API using the Pokemon argument or parameter that's been passed in. So at this point, a lot of people ask, why are we mocking all of these responses? We create these tests, and we're calling these service methods, but we just put the response up there, and then we just return that in a test. That doesn't make sense. Why are we mocking these responses? And I think the best way to think about this is to think about the night before opening day if you run a restaurant, right? You've already tested your cooks. You know your cooks can cook their dishes. Everything's good. But what you want to do is test that your front end, your waiters and waitresses, can handle the responses from the back end. So if your waiters and waitresses are going to the kitchen, they're either going to get the meal because the meal's ready, or something bad might happen, like the meal's delayed, you ran out of ingredients, something like that. We mock to test those two scenarios, or three scenarios, right? Because we want to make sure our waiters and waitresses can go to the kitchen, get a meal, take it to the customer, or if something goes bad, you run out of ingredients, the meal's not ready yet, they're going to go back to the customer and apologize. Say, sorry, we can't make this, you want something else. If we didn't mock that back end in our test run, we would literally be waiting until our kitchen ran out of ingredients, which we probably don't want to do. All we care is that the front end can actually handle that response, that they can handle a dish being made, or they can handle a dish not being made and apologizing to the customer. So that's why in our tests we mock the responses, because we want to verify that our front end can handle a successful response or an error and display that successful response or display the error to the user. That's why we mock. So hopefully that clears it up a little bit. And then finally, testing a component. So this is kind of like the more visual testing. It's not end-to-end just yet. But actually, let me go to the component first. So in the component, we would have something like a user's property. In our ng-init method, we would call that user service to get all of those users, setting it to that user's property, and then we would iterate that through the HTML to create something like this. In our tests, once again, we start off with a mock class that returns, in this case, just one user. And then within our testbed configuration, we actually use this thing called providers, which basically says, okay, our component needs a user service, but again, we want to mock that user service. So we set it with this weird little syntax. We do provide user service, and we say use class being that mock service we've set up on the left. And then in this before each, some weird syntax, but We use this testbed to actually create the component, and then we have this thing called fixture. And fixture is basically what allows us to have a handle on the visual representation of our component. So this component down here is actually like component class and all the properties that we saw here. Fixture is more of a way to kind of access what's in the view related to our component. So if we go down here, we would do something like fixture.debugElement query. You can kind of think of this like jQuery, just a little bit more robust, but we're querying that view for these names, and then we set our expectation that the text content of that element has the name equal to Jane. So again, that would be what the component implementation of this would look like. Don't have the HTML, but it just iterates that. Yep. Yep. Yeah, so in this case, like right here, user service. So we have our user service being injected in, but in the test scenario of it, we actually override that. Because again, we might want to test in a scenario where there are no users or where we get users, we might show two different things. We might show where if there are users, we display the users. If there aren't any, we display an error message. So with this kind of mock, I don't have another example here, but with a mock like that, you can actually create two different mocks and test those two different scenarios. So like right here, you could have another if statement below this with a different mock that says there shouldn't be users, instead there should be an error message displayed to the user. So, yep. Yeah, so you just do that little providers thing right there. Yep. All right, and then finally, end-to-end testing with Cypress. Thankfully, I think Cypress's syntax is a bit easier to work with. You don't have all this testbed and debug element, all this stuff. You pretty much just chain everything off of CY, which stands for Cypress. So like the first thing you do, you pretty much do this in every test, you just configure what your base URL for your application is. In Angular, it's just this local host. Then we have a little before each right here that says, all right, visit the root path of the application. And then we have our various tests. So we say like it should display users. And you just have all of these different kind of dot methods. So you say like dot column, which would just be the class of the column for each user. And then you can just do these assertions like should have length as 4, or you can even do like greater than 4. Again, there are a lot of different types of matches you can use. Down here you get, again, maybe should have had some of the HTML, but there's a little Pokemon attribute, which is what's used to actually get the Pokemon using that Pokemon service. You just verify that that shouldn't be empty. And then you can even do stuff like this where, you know, if you have like a username hyperlink, you can get that username, and I use first because there's the 4 columns that were displayed in the view. So you say get all these usernames, you do dot first to get the very first user, and then you can just click that and then make an assertion on the URL that, you know, it should contain the user profile URL that you expect. And then one more here. Again, a lot of the setup up front, you configure your base URL. We do it before each because we want to. Go ahead. Yeah, so that's within the framework. They're pretty explicit within the documentation. They have a bunch of different. Yeah, exactly. So they're Chai and Mocha assertions. So if you've used those frameworks, you probably are familiar with them. But either way, within the Cypress documentation, they list a lot of them for you. So the good thing is, like, once you kind of use a few, you can kind of predict some of them. So like here, instead of that not empty, you just get rid of not. Be empty would be the opposite of that. But yeah, it's just one of those things within the framework you have to learn. But it's all within the Cypress documentation, and they have a bunch of different type of assertions you can make. And there's actually one more here, actually. So again, if we do the kind of, now we're testing the user profile. So before we do any of these tests, the first thing we do is visit that root directory We find the name, we click it, we make sure that we're actually going to the user profile page, and then you can just do something like this where you do get the avatar, which would be the class on the image, and then we just do should be visible. So we just make sure that there is an image there and it's actually displayed to the screen. And then, yep. Mm-hmm. Yeah, so everything in Cypress, from what I understand, everything is a promise, but the thing is, whenever you're writing it, you can write it synchronously like this. So even though it goes through and it's, it's querying for all of those column elements and then it's grabbing the first one, as a developer writing this, there's no like waiting that you have to do. You can just write dot first, dot click, and it just waits for that to resolve if it needs to. So it's not like, again, with Protractor, I think you would actually have to do a dot then and then write your test. Everything here, you just kind of chain it off of each dot method. Mm-hmm. Yeah. Yeah. Yeah, so that's the other thing. Like if you have a really long test, sometimes instead of just like chaining these one after another, it makes sense to kind of break them up into little groups because there might be like 3 different sections on your form, and you want to break those up, with white space into 3 visible chunks. You can just, that white space is like completely ignored by Cypress. It just goes through in sequential order and runs them as you expect. So that's everything I have. Yeah. I was wondering if there's going to be one comment. I went to that game, actually, for my dad's birthday. Yeah. Mm-hmm. Yeah. Cypress. Mm-hmm. Mm-hmm. Yeah. I'm not sure. I think they are working on it, Toby. I'm not sure if you know. I think they're, yeah. That's one thing I've heard. I think they are working on Firefox pretty actively. Right now it is just Chrome, I think. Chrome and Chromium, I think, are the 2. But yeah, as of right now, I think you're just out of luck with that. But yeah, I think they are working on it, and they're always releasing features. Like literally every time I open Cypress, I have to download a new update. So they're constantly pushing on code. I'm not sure off the top of my head. There might be some Medium posts out there that they've done, or if you go to the Cypress website, they might actually have some section, if you're coming from Protractor to Cypress. But I think that so when you set up Cypress, they have this file that's created for you called Kitchen Sink, and it has like 100 tests written within it. And if you just go through that and kind of read through it and then run those tests, I think you'll find that transitioning from Protractor to Cypress is going to be a little bit easier than you expect. Because, I mean, if you're already using Protractor and you already know it's a nightmare, Cypress is going to be a breeze. So I think if you just look through that kitchen sink demo and then just, go through the documentation, I think you'll have a pretty good handle on it. Yeah, it's awesome though, seriously. Don't use Protractor. Yeah. Yeah. Yeah, I mean, everything that would be Angular specific really would be like all of these kind of setups, all these testbed setups. But as far as like the principles behind it of like mocking services, subscribing to those services and making assertions about it, it's pretty much the same in like every framework. And the good thing is once you've used one testing framework and you move to another, the syntax is pretty similar. Like the only thing that really changes are these matchers. So like here it's 2 equal. I think in Mocha it's .2 equal. So those are like the huge jumps you have to make. But once you know one testing framework, you can kind of read other ones and kind of figure out what's going on. So, yeah. So Testbed within Angular, it sets up whatever you're providing it. So like in this example right here, I'm testing the home component, and because home component has a dependency, I'm specifying user service. So it's not really spinning up the entire application, every other component in your application. It's only spinning up home component and the services that you're providing it. So, and that's the thing about testing is you should typically be testing things in isolation until you're doing something like end-to-end testing or integration testing. So whenever you're testing something in Angular, Testbed, you're providing it what should be tested. And in this example, because home component has the user service dependency, if you don't give it user service, it will tell you. It'll say there's no provider for user service, you need to give it that. So Testbed just takes your component, your directives, whatever it is that you're testing, and just creates a version of it within your test that you kind of interact with. Yeah, so that's the thing. Testing is an art more than it is a science. It kind of depends on your needs, but when I do some of these kind of like, some of these tests that actually query the view, I try to keep them pretty simple. So to me, it's almost like what matters about that feature. Like what's the most important thing on that page? What is like a business critical piece of information that needs to be there? I'll test that kind of stuff. But if it's just some like extraneous, like I'm not going to make sure every single paragraph tag is visible, that kind of thing. But then it's also this balance of, okay, where do you do a test like this versus where do you make an end-to-end test that actually spins up the browser and clicks through the user flows? There's no real concrete answer to that, because again, it's kind of more of an art than it is a science. But I think it just depends on the situation, how critical the flow is to your application. If it's something like a payment page, you probably want to test that pretty heavily, where if it's something like a team page, I don't know that I would bother to test that at all. So it depends. Yeah. Yeah, so again, in that scenario, you would kind of take all the different inputs that you would expect to actually be able to handle. So Mhm. Yeah, so with something like Cypress, you can kind of factor performance into it a little bit. So, if you want to make sure that something's going to be visible under a certain amount of time, you can actually query to make sure that's visible under a certain amount of time, or you can, make it wait for a certain amount of time. You can actually do this thing called .wait and wait a certain amount of milliseconds. Well, with something like Cypress, you would actually be hitting your API. You'd probably be hitting some sort of test database. But once you get into performance, I start to think that kind of leaves the testing realm. because performance is kind of another issue, whereas testing is saying, okay, if I type in results and it's taking too long, do we show an error message? Do we have some sort of UI element to say, hey, something went wrong here, maybe refresh the page? Once you get into a performance thing, I think that kind of leaves the testing world. Then you kind of get into, okay, why is this happening? So, but you can do things like that where you can say, you know, if you know you're going to be on a slower 3G connection, and as the user's typing an autocomplete, if you want a message to say, like, we're still retrieving results, you can make tests to verify that that is actually going to be there. So. Yeah. Yeah, so user service is the actual service within the application. Mock user service here is basically just like a copy of that. It's like a dummy of that we're just using for our tests. Yeah, so it kind of depends on the scope of the project. For something small like this, I just put the mocks above it. But if you get to something where you're duplicating this over and over and over, you can actually have, I think they typically call fixtures, where you just have a folder basically for all of your mock responses, so that you're constantly just importing from this testing directory that has all these sample responses. So it depends on how big your project is. If it's pretty small, I tend to just throw them right in the file. If it's like a huge JSON response that gets ugly, I might throw it into its own file within that same directory and just import it. It just kind of depends. But I've seen anything from within the same file to a separate file to its own directory, just depending on the scale of the project. Yep. Mm-hmm. Mm-hmm. That's why here it's actually a limited response. Yeah, I just cut it down. Yep. Yep. So that's something a lot of people ask. That's going to happen, but in that case, like, you have to think about what an API is. An API is a contract between the backend and the front end. It's saying, if you give us this, we're going to give you this. If they change that, they've broken their end of the contract. So hopefully they have some sort of semantic versioning in place so that, you know, it's not just going to change it on you. It's like when a framework changes certain methods, like they added pipe, I had to go update my entire book. So So whenever that contract changes, that's just an inevitable thing that's going to happen, and then you have to change your responses to kind of map that contractual change. But hopefully they're not just doing that haphazardly, but sometimes, you know, it does happen. Yeah, that's happened before. We've had a test where we're hitting, like, I think Zomato at a previous company, which is kind of like a Yelp thing, and they just removed a field out of nowhere. And, you know, we didn't notice it until we went into the UI and realized, oh, this isn't displaying anymore. And it's obvious, it obviously sucks, but at the same time, they really shouldn't have done that either. They should have kind of given some advance notice saying, hey, here's this contract we have when you're hitting this API route, and we're now going to change this property name to this property name. Prepare in advance, or like lock down your version. So it's one of those things that's going to happen, but yeah, once it does, you kind of just have to account for it. There's always going to be like a little bit of manual work that you have to do. But yeah, that's one of those things, unfortunately, it's going to happen. Yeah. You're talking like specifically back-end and front-end communication with developers? No, I've typically always worked as a front-end or full-stack developer. But usually there's just communication between the back-end. Like as we're developing features, you know, we're saying, okay, what are the various endpoints that you're exposing to us? What do you need? What are we going to get back? So you're establishing those contracts up front. And then once you kind of have those contracts established, then you can kind of work from there, right? It's similar to if you were to go to like a Twitter API or Facebook API. They have all these responses listed. So there just needs to be a lot of communication between backend and front end about what they're expecting, what you're going to get, and then if they hold to that contract, you can basically take those mock responses, run with it, write tests, write front-end code, and hopefully everything plays nicely. Let me go back. So the SPY here, I just use the SPY for that because in this example, it's a pretty straightforward response. Like, hold on, so this SPY versus, because I just have a, short response up here, and I'm testing the actual service here, you don't have to set up a mock because you're already getting an instance of your service within this test. Whereas in the component test, you're actually providing the service to the testbed configuration. So in the service test, it's giving you an instance of the service, so it's kind of already been created, so you don't get to create that mock. You have to just say, okay, here's a method, provide this on as a return value, whereas here, you're setting up that service before it's even been created, so you can kind of use that mock. You can use SPYs here, though, if you want. No, so here, like, if I was going to need to test, like, a success and an error, you could just, hold on, actually, let me go here. So if I needed to test a success response and an error response, what I would actually do is probably leave that mock user service empty, so it just has the method, and then within the test, I would create the SPY and set the return value for the two different responses. Yeah, because in the service, it's being created within Testbed, whereas here you're providing it to Testbed. So just a slight difference. Yeah, but if you actually just use the real service and it's actually hitting the real API, you wouldn't be able to test like an error response. You'd actually be. Yeah, it depends. But either way, like when you're using this HTTP controller, you're having to like specify that response anyway. So that's kind of like your spy there. Yeah, so earlier we were just doing like a hard-coded set of users when we're actually having a service that makes a request to an HTTP endpoint of some sort. Rather than like creating that mock class and saying return this value, what we're doing here is instead saying that we have this HTTP controller that allows us to kind of do some various things with that request. And what we're doing here first is saying this is the endpoint that it should be hitting. So we have the service method, this is where we expect the request to be made to. And then below that, the flush is basically saying, here's what we want to return once that endpoint is hit. And then below that, we do our expectation and assertion like normal, but if in your service you were to change that endpoint, change it to something else, that whole thing would fail because it's listening on a certain endpoint, and once that endpoint is hit, it's kind of intercepting that request and returning a response. So it's just a way to kind of spy on that HTTP request and give return values you want or to make actual assertions about the right endpoint being hit. The test will fail. So right here, it'll actually say like expected request to this endpoint, and instead it was this endpoint. So if somebody went in here and tried saying, oh, there's this better endpoint that we can use that'll still give us this return value, it would fail. That test would fail. Yeah, within your test, it prevents the request. Yeah. Yeah, so it never actually makes that request. That testing controller is basically what allows you to say, catch this request and throw something back instead. Yeah. Yeah. No, so my book, you create an entire Angular application from scratch. You make this event form where you create forms. You get to use the Google Places API. You get to use the Zomato API. I provide an API for you, but everything in the book is tested. Because when I was working at a previous job, it was with AngularJS. The resources for testing were limited, and I basically had to teach it all myself. It was insanely frustrating. So once Angular 2 came out, I decided to just capitalize on that. So everything in the book is tested. It does unit testing, a little bit of integration testing, Cypress testing. But yeah, it's 500 pages. You make an entire application, authorization, logging in, test database, live database, deploy to Heroku, third-party APIs, libraries, all kinds of stuff. So, I mean, it's 500 pages of material, ton of stuff in it. Yep. Yep. Yeah, it's really cool. So all of these, yeah, like you said, all of these cy.gets.first, it has this little column on the left, and you can go through and it'll highlight in the DOM exactly what it's doing. So like this .get data test name, it'll highlight all those columns, and then you go one step down on first, and it'll highlight that first one. So you get to see everything that it's doing, which makes debugging way easier. protractor is like figured out. You have this like cryptic error message. Seriously, Cypress is so good. Yeah. I'm not sure. I think I've never had to use it. I've never used them yet, so. Yeah, I haven't tested iframes. Mm-hmm. Yeah, they're really good. Yeah. Yeah, I haven't had to do it yet, so. Anything else? So it's codecompanion.io. Yes, I have beginner JavaScript tutorials there, some Angular tutorials there. Book as well. It's on Amazon. Self-publishing is awesome. Cool. Good?
I like that you